Hi, this is Mr. Ward, and this is the Algebra Do Now key for B block 35.2 or A block 36.1 or D block 36.2. So here we go. So we're going to take a look at a real-world situation. So this is known as the free fall equation. And the free fall equation is based on three components for an object that is falling in gravity. So the first component here, the x squared part, is based upon the distance an object will fall based on time and its gravitational acceleration. Since the Earth's, it's 1/2 acceleration times time squared. So x is x squared. Gravitational acceleration of the Earth is about -10. It's really -9.8, but I'm rounding it for the purpose of this. So I'm saying -5. You would in meters per second, that is. So this first part is half the acceleration of the Earth, it's negative because it's down, times time squared. And that'll tell you the distance for any amount of time if something is accelerating. But if something was also thrown, it's going to have an initial velocity. So speed or velocity times time is going to be 10 velocity times x in this case. So velocity, our initial velocity is 10 meters per second. The rock was chunked straight up at a vertical velocity of 10 meters per second. So 10x tells you the distance it will have traveled if we ignore acceleration or what the starting point was. Okay, now this just plus 2 is just how high it was when it started. So we put all of that together and you've got starting place, how fast it was going in the beginning, and how fast that speed was changing every second. And all of that put together gives you a free fall equation. So we have a situation where we're on the Earth, we're ignoring air resistance, and we have an initial speed of 10 meters per second and an initial height of 2 meters. All right, but the question here is a simple one. What are A, B, and C in this quadratic function? Okay, well, A is going to be -5 because that's the x squared coefficient. B is going to equal 10 because that's the x or linear coefficient. -5 is the quadratic or square coefficient. And 2 is the constant coefficient. C is 2. Okay, C is the constant in the quadratic formula, and the quadratic equation, I should say. So now we know A, B, and C. Let's go down here to figure out what the b squared minus 4ac part, because that's probably the most complicated thing to deal with in this quadratic formula. So we've got A, B, and C are that. Okay, and we're going to do b squared minus 4ac. The name of this part of the quadratic formula is called the discriminant, because if it's positive, you're going to have a plus or minus version of your answer. So you'll have two solutions in the real number system. If it's 0, then the square root is going to be the square root of 0. So we're not going to care about a plus or minus. You're really just going to have one solution. Your parabola will touch the x-axis once. And if b squared minus 4ac is negative, in other words, if 4ac is more than b squared, if it's negative, you're getting a square root of a negative number, which requires you go outside the so-called real number system and into a system called the complex imaginary number system, which is a real thing and really matters in the real world. But it does mean you will have no solutions in the real number system. Your parabola will never touch the x-axis. So its vertex will either be above and it'll open up, or the vertex will be below and it'll open up downwards. Okay, enough of all of that. We're going to deal with B, which is 10. So that's 10 squared. We're going to deal with A, which is -5. And we'll not scroll down so fast. We'll deal with C, which is 2. And so let's deal with the 10 squared. Let me copy pasta this thing. 10 squared is 100. 10 times 10. Then 4 times -5 is negative 20. And negative 20 times 2 is negative 40. And you might notice we have a minus here, so that's plus. And then that means that our b squared minus 4ac is 140. And now we're going to see if we can plug all of that stuff into the quadratic formula. So I'm going to go right in here and go to the quadratic formula here. So we know that b is 10. So we'll replace b wherever it shows up. Okay, that's negative 5 for A and 2 for C. And now we start simplifying. I'm going to start off with this. I'm using, of course, the plus version only right now. Let's deal with this in the bottom. That's 2 times negative 5 is negative 10. And then we already worked out that all of this business was just 140. And now we can break 140 into 4 times 35. Okay, and since I can break 4 times 30, that into 4 times 35, I can pull the 4 out of the square root jail, get the square root of 4, and it's 2. Now, before I go to the negative version, what I'm going to do is I'm going to factor a 2 out of top and bottom. So the negative 10 becomes a negative 5, the 2 becomes a 1, and this negative 10 becomes a negative 5. All right. Now we'll deal with the plus or minus version. Okay, because there's a plus or minus square root of 35. And the one last thing, we've got this negative 5 in the denominator. Let's get rid of negative 5 in the denominator. And the way we can do that is multiply top and bottom by negative 1. In other words, you're just going to reverse the sign of everything. So that'll become positive, that becomes negative, and that becomes positive. And we're going to do the same thing in this version. So positive, positive, positive. And so we have now 5 plus or minus the square root of 35 all over 5. And those are our solutions. So let me go back in here. So we've got our answers are going to be 5, I'm going to put it in parentheses, 5 plus or minus, which represents 2 versions, square root of 35 all over 5. Now, if you had left it at negative 10 plus or minus the square root of 140 all over negative 10, I would accept that answer at this stage, but I do want to coach you to be looking for ways to reduce all the stuff. Reduce the square root, simplify the square root if you can, and then factor out any common factors of numerator to denominator. Make sure your denominator is not negative, like I've just done in this video. I hope that was helpful.